Welcome back to my channel. Today we are going to see how the logic will be applied in theory of computation, and we are having the different logic: prepositional logic, Boolean logic, and first order logic and predicate logic. So we will see one example for each logic, then we can understand. Yeah, first one is we will see how the predicate logic will be. First we'll see how the prepositional logic will be used. Prepositional logic. Okay, so what is actually prepositional logic? So it is deal with simple true or false condition. True or false condition. For example, in ATM machine, how and when the card is accepted. Both username pin. First you have to insert the card, then you have to enter the pin number. So both are correct only. The machine will be accepted our ATM card. So this is example for prepositional logic. Okay. For example, in TOC, if you are entering the starting state, so if it is the state A means it will be continuously running on 1. Otherwise it goes to next state. That is, if it is 0, it goes to next state. So like that we can represent the state as well as a logic. In that case we can use prepositional logic. So next one is predicate logic. Predicate logic. What is predicate logic? It deals with objects and properties. So here object and properties. So here what is object and properties in this ATM machine means, we can say how many user we don't bother about. If n number of user, the card must be inserted as well as the pin number should be correct one. Then only valid card also, then we can get the money also. So it will possess some objects and properties. So here object and properties is card is object and properties is the pin number should be in correct. Okay, so here they are dealing with some objects and properties. Okay, so next one is first order logic. So first order logic, some complex relationship. First order logic, here you see it describes some complex relationships and constraints. Relationship and constraints. For example, if user attempt, that is pin number, user attempt greater than or equal to 3 times, okay, it is blocked by the machine. So here the same object and properties, username and pin verification, but here we are having some constraints, some relationship. Okay, so like that we can apply the first order logic. Next, Boolean logic, as it is either true or false. So here we can use Boolean logic circuit level, Boolean logic circuit level and logic level also. If you are entering the pin number, for example, ATM pin number 1, 2, 3, 4, 5. So if you are entering the 1, this 1 value is matched by the database. So if it is true, it is represents the true value, that is a 1. It is represents the true in the machine. Again, next number it will be checked by the machines. It is matched by the database. Automatically it will return the true. If it does not match, automatically return false. So in the situations we can use the Boolean logic. Okay, so whatever we are having the problem, we can provide the solution using the predicate logic, first order logic or Boolean logic, as well as prepositional logic in theory of computation. Especially we can design our machine based on the problem. So this is here logic behind the theory of computation. So preposition logic, predicate logic, Boolean logic and first order logic. So this is again one more example. The same thing, login authentication systems. So the username correct and password correct, the login will be success. And also set theory, we can organize all the possible username, password and system date. So we can represent the state by state, that is the sequence of actions. And finite automations could represent the login steps, that is correct or incorrect transitions. So everything represent the same steps. We can represent state diagram, that is starting state, then ending state. So like that we can apply the logic for designing the automation. Thank you.